So, Consumer Watchdog Organization estimates the mean weight of 1 ounce fun-sized candy bars to see if customers are actually getting the full value for their money. A random sample of 25 bars is selected and weighed, and the organization reports that a 90% confidence interval for the true mean weight of the candy bars is 0.992 to 0.998 ounces. So, based off of yesterday, I'm giving you the green dots as being 0.992 and 0.998. So I'm still missing 2 colors there. The colors that I did yesterday would be my orange dot here, and then my blue lines connecting those. So A asks for what is the point estimate of this sample. What color is the point estimate? That one in the middle. But how do I know what the value of it is? It's right in the middle, so you just find the middle of the two. So even though it doesn't actually give it to me, if I know both my endpoints, they're the same distance away from those endpoints. So what is my point estimate here? 0.995. And what would my symbol for that point estimate be? X bar. And what are my units here?
I don't understand the wording of it when it says like it meets the report said 90% confidence interval is blank and blank.
It's giving you the green dots. Like we did a 90% confidence interval on one sample and got those green dots.
Oh, okay.
Alright, so part B says, what is the margin of error? Well, where up there is the margin of error? The blue lines. And it's each way. So how far is this blue line?
0.003 ounces.
So what is my margin of error?
0.003 ounces.
0.003 ounces. Alright, so I changed this entirely. I just condensed it down to say this. So these are our 2 interpret sentences from yesterday. So in trying to keep them separate, interpret the confidence interval. The interval is the percent or the 2 green dots. Is the interval the percent or the 2 green dots? The 2 green dots. So the 2 green dots are specific numbers, right? From my data. So when I am interpreting the confidence interval, I am interpreting in context using specific numbers from my data. I would go ahead and get out whatever you wrote on your notes from yesterday so that you're kind of looking at this as you go along. So not that this is the important part of it, but people typically used to end up connecting, interpret the confidence interval starts with we are. So we are what? How much?
90% confidence.
That what? So what is my parameter that I'm trying to estimate? That mu, which is and I'm going to be as specific as the problem here. 1 ounce fun size candy bars. And then what from, so I haven't used data values yet, but I know I do because of the confidence interval. So what comes after that? Just following your notes in front of you. Falls between. So what am I going to put as my lower? And what are my units? And so when we're interpreting confidence interval, I actually give numbers from my interval that I got, my data. As opposed to my other interpret sentence, this one wants me to interpret confidence level. Well, that's just the percent. So if I'm talking about the percent, I'm not going to be talking about where my green dots actually were. So where do I start? 90% of, well, I know that the 90% doesn't apply to just one, it applies to, and then so that's really important. And the second important part is it's not just all possible samples, but it's all possible samples of how many did we sample? So 90% of all possible samples that we take of this size from this population will do what? What are we trying to capture? Which is what?
True weight of 4 ounce 1 cell kilograms.
What's the most annoying about this?
We
keep writing the same thing over and over, right? We're finally at the point now to where we've gotten process down. So anytime I write something, don't write this. You know how I write that and then I say, let this mean this? I can literally use that at any point in time with anything. I could write something that means this and write that every time instead. I could define this and then just write that every single time instead. So we're kind of at the point where we can, if you write it once, then you can reference it from then on. So even though this is the true correct answer, we're going to start kind of shorthanding it a little bit, as long as you have a key up to the top. And then I added one more problem on there, just because I wanted to practice one from yesterday. What's the last question? Find the critical value for this problem. So what's the only thing I need to find critical value? On the paper, sorry. What's the only number I need to know to find critical value? So I have my graph. How many lines do I draw? 2. One on the left, one on the right, centered. This part is 90%. What do I do with 90%? 100 minus that, which means I'm left with how much? 10. What do I do with my 10%? So in this tail is 5%, which is 0.0500. exactly perfectly between negative 1.64 and negative 1.645. No, negative 1.64 and negative 1.65. This is the one that we go to 3 with because it is literally exactly between. So our Z star, which is our critical value, is 1.645. And just to talk about, refresh from yesterday, why do I say that I do the star? What does the star mean? Positive and negative. Because if not, I'm writing an equation that ends up being like this. And then I'm also trying to write this beside of it. So the equation is positive, negative. Your Z is positive, negative. That gets complicated. And so we just use that instead.
Wait, so why do we use the 1.645 one? Instead of the other one that was split?
It is exactly split between 1.64 and 1.65. So it's because it's exactly between, that is the number that's exactly between. All right, so the only thing I don't think I mentioned in this class yesterday is we said we're finding a what? What's the term? Critical value. So the critical value, so here is shaded. Here is shaded, here is not shaded. So the critical value is the line that defines shaded and not shaded. That's not the definition of it, but that's why it's the critical part. So it's critical for defining if it's within the interval or it's not an interval. A question thing on the left side.